So to start off, I'm going to let you know that you can download this code in the link below. Before you go and download it, I'd like to explain how this works. For those who have not seen or heard of virtual masters, let me describe what it is. Basically, it's a short piece of code that produces either a speed or some other kind of signal that other devices are going to follow. By sending out the signal to all the follower drives would be able to use that signal in however method they're supposed to do exactly what they need when they need it. So this virtual master that I produced is a very simple virtual master, and we're going to make a fancier one later with some fancier blocks and features. This one should be a good one for those who are new to the virtual master kind of concept. So the first thing I'm going to do is I'm going to look at the library manager, and the reason I'm going to do that is because this virtual master, I am using one of the blocks out of the CT Advanced library, and it's a very simple block. It's found under ramps, and it's called the slew block. And really all it does is it takes an input and it ramps the output to the same value you have the input. So this is basically producing most of our virtual master here. Now I'm not going to be using everything of the slew. We are not going to be using the reset, and we are not going to be using the queue. Okay? However, the queue might be a very handy thing for you in your application. Basically what it says is it says the output of the function is the same value as the input. In other words, I want to go 300 RPM, it ramps up, and once it gets to 300 RPM, the output says 300 RPM, and Q also says true. We're at speed. Okay? We're not doing that. We're just using the output, which tells us what speed we're currently supposed to be at. We're using the ramp rate, which controls the rate at which the system accelerates and decelerates, and we're using the input as this is the speed I want to go. Alright, so over here in the virtual master, let's go look at it. At the top of the virtual master, you're going to see I have two groups. The first group here is called the variable inputs. These are used to set up what speed I want it to go, what the accel rate I want it to be, and whether or not we're going to run or stop. And these are the internal variables. But like I said before, we are not using the reset, and we are not using this at target. Before I referred to it as Q. So this is how the code works. The first thing I do is I check to make sure the acceleration is not negative or 0. Because if it's 0, you'll never ramp up. The next thing I do is look at these 4 lines of code, and I set the input speed, or the speed input, however you want to look at it, equal to the commanded speed. So say I want to go 100 RPM, it's going to set the input speed to 100. But then if the run command is false, it's just going to set the input speed to 0. Basically, I'm not going to listen to whatever speed it is. That's what this line's doing. Now, the input speed just gets passed to the slew block. That's this function right here. And you'll see that the input is equal to this. And that's all this slew function needs to really run. And it's going to automatically ramp up. And as it ramps up, the speed output will change. And then the speed output, in my case, I'm mapping it to parameter 32008, which is just a parameter in the AMC. But you could map this to a preset speed reference or something. You might need to scale it a little bit to get it in RPM if your units aren't in RPM to start with. Now let's go look at the freewheeling code. Now the freewheeling code is like the background code. I wrote this in ladder logic because a lot of people like ladder logic. And what this is doing is controlling our virtual master. So here's our virtual master code, and here's our freewheeling code. And the first 2 lines here, or first 2 rungs I should say, are used to give it a forward velocity. So this one starts it. So you'll see this parameter 8004. This is my digital input 4 in this drive. And I'm going to give it a acceleration. So I'm going to move a 500 into the acceleration. And I'm going to move a value of 1000 into the speed. And then after that, I'm going to say run. That's what this line does. It's on a positive edge. When I remove input 4, I'm going to remove the run command. So it basically will ramp down and stop. And I'm doing exactly the same thing with these 2 rungs. The only difference is the speed is negative, and so we'll be jogging in the opposite direction. So let's go try this. So I'm going to go online here, and I'm going to show it one time without the scope, just so we can see the display easier, and then I'm going to show it with the scope so you can see it actually doing it. So I'm going to turn on input 4. You can see that that's on, the run command's on, and we have that value. I just turned off input 4, and so it has removed the run command. Now I'm going to do the same thing with input 5, and you can see now I have a negative speed velocity. That was fun and all, but let's actually see it do something. So here's our graph. Our graph has a yellow line and a red line, but you can also see that at the bottom you can see the input states of digital input 4 and digital input 5, so you can see when I turn them on and off, just to show you that this is truly working. So I'm going to turn on input 4, and you're going to see it ramps up, and then I'm going to turn it off, and it stops. You can see the red line was the speed accelerating up and decelerating back down to 0. I'm going to do it again with input 5. Okay, see. So you can see I can just keep going back and forth. And if you want, you can send this virtual speed value over the network and have multiple drives follow this speed reference. Yeah. If you want to see how to make an even better virtual master, click here. If you want to see something else that's pretty cool, click here. And like always, click here to subscribe.